Hey class, today we're going to be looking at section 4.14 or 4.14, part 1 for AP statistics. We're going to be looking mostly at the general addition rule, which is for the union of two events. So let's start with an example here. A survey of college students found that 56% live in a campus residence hall, 62% participate in a campus meal program, and 42% do both. So in the last lesson, we talked about this rule that we're going to use for the probability addition rule, but the examples we looked at didn't have any overlapping pieces. So today we're looking at what happens when there's an overlapping part. So here, 42% of the students do both, live on campus and participate in the campus meal program. So that's where today's lesson is a little different than yesterday's. Apply the rule to find the likelihood of randomly selecting a student that lives in a campus residence hall or participates in a meal program. So the first thing you need to think about, again, if I ask you to stand up if you are wearing a black shirt or a blue jeans or blue pants, then if you're wearing both of them, will you stand up? Well, yeah. If I'm wearing a black shirt, then I would stand up, whether or not my pants are blue or not, and so forth. So or means one, the other, or both. So all of those things are included when we say or. Now remember, AP Stats, we need to write a probability statement. So I want to find the likelihood of selecting a student that lives on campus, or, so the union of these two things, or has a meal program. You don't have to write all the words. What I've written is just fine. Now using our rule, so the probability of A or B equals the probability of A plus the probability of B minus the overlapping section A and B. So that gives us 0.56 plus 0.62. Now, if all I did was add those two together, I would have more than 100%, which doesn't make any sense. So this is where subtracting that overlapping piece comes into play. So when we type or put that all into our calculator, I get 0.76 or 76%. On the AP exam, you can leave it as a percentage or decimal, it doesn't matter. Now let's talk a little bit more about what subtracting that 0.42 does in our formula. I mean, it makes the numbers work out, but why are we taking them out if we want to count the people who do both? It seems counterintuitive to subtract it. So let's really look at what's happening. So we can use Venn diagrams or tables to kind of organize our information. Remember the part where students are, if you've never seen a Venn diagram before, the inside part where I just did this to it is the part where students are both on campus and have a meal plan. So that is that 42%, 0.42 in here of the students that do both on campus and meal plan. Now, if I were to just put 56% in here, I would be wrong because this represents on campus but no meal plan. Oops, that doesn't look like meal plan. So the crescent shape of that without the overlapping shaded region is just how many students are on campus but don't have a meal plan. So if 56% of students live on campus total and 42% have a meal plan, I need to subtract those two things to get how many students live on campus and don't have a meal plan. Again, here, similarly, meal plan, this represents meal plan, but not on campus. So if how many? 62% of students have a meal plan and 42 live on campus, then 20% are going to have a meal plan but don't live on campus. Now, finding how many students live on campus or have a meal plan doesn't mean that I'm not including the both. It just means I'm only including the both piece once instead of twice. So if I were to take just 56 plus the 62, I would be counting that 42% with the 56%, and I'd be counting it again with the people who have a meal plan. So I don't want to count those 42% of the people twice. which is why we subtract it once. So the probability of on-campus or union meal plan can be found in two different ways. We saw it found with the formula above. You could also, if you make this diagram, you could also just add the pieces. So it could be 14% that live on campus without the meal plan, or 20% that have a meal plan but don't live on campus, or the people who have both. And if you add those together, you'll also get 76%. So this is the same as if I take 0.56 plus 0.62 and I subtract 0.42. It's not because we're not including the 42%. We just are only going to include it once, and we're not going to double count it. All right. So moving on to the next page here. Our Venn diagram wasn't quite complete, actually. Let's go back. If that's 76%, in stats, when we make these Venn diagrams, we actually have a fourth option. We have on campus, no meal plan, not on campus. We have both. What about the people who don't have a meal plan and don't live on campus? Since we know that only 76% of students participate in being on campus or meal plan, then that leaves 1 minus 0.76 is 0.24. And so that kind of goes outside of our circle. That represents neither. So we want to include that when we do our Venn diagrams as well. Instead of a Venn diagram, you could also just make a table. I'm more of a fan of tables personally, just because I'm a more linear thinker. I like straight lines and boxes more than circles. But and I find that the meal plan has a little bit more information, or the table has a little bit more information for me. So the meal plan is, remember 56% lived on campus. So lives on campus, that 56% is actually going to go outside of the box. So think outside the box. 62% had a meal plan and 42% have both. So it's the intersection of the two pieces inside. This is how I would take the information I was given in the problem and put it into our box. Now, and I'm going to do this with a different color here, I can find all the other pieces. It's supposed to add up to the outsides as you go across or down in the table. So that would make this 0.20 so that it adds to 62%. That would make this one 0.14 so that it adds to 56%. I want all of this to add up to 1. So I can figure out, okay, if 62% have a meal plan, how many don't? Well, that would be 38%, so that it adds to 1. 56% live on campus, so how many don't live on campus? That would be 44%, so that it adds to 1. And then I can use those and what's in my table already to figure out that this no meal plan and not living on campus is 24%, so that it all adds up nicely. So what we get that we didn't see in the Venn diagram, if you notice, we have 4, 5, 6, 7, 8 numbers here. If we look inside and outside our box, not including 1.0. And we only had 4 numbers in the Venn diagram. So we do have some extra information here, which is nice to see. Nothing we can't figure out from the Venn diagram, but I like seeing it. All right. So there's our general addition rule again. We wrote it above and we did it in the last video. Let's look at the next example. 2 cars, A and B, arrive at an intersection. The probability that car A stops at the intersection is 60%. So I'm going to start by putting 60% down here on my table. So A stops, the total percentage is 60%. That goes outside the box. Probability car B stops in the intersection is 70%. That goes outside the box. The probability that they both stop is 40%. Now, at this point, I can finish my table. I could also put the 40% here and figure out the rest of my Venn diagram as well. If, let's see, I like using different colors here. If A stops and B stops 40% of the time, then A stops 20% of the time that B doesn't stop, so that it all adds to 60%. So that's going to be this part of our Venn diagram. This is going to be 30%, so that's going to be B stopping and A not stopping, 30%. And then what's left over? So if I have 30% to equal 1 and I have 40% to equal 1, then this spot needs 10% there. So again, you can do either one, the table or the Venn diagram, whatever one you prefer, whichever one makes most sense to you. You do not have to do both. Now for probabilities, doing those tables is showing your work. So when we do the probability, first we have to write that probability statement. So car A stops or union car B stops. So we can use the formula. We can just add up A stop, B stop, and both stop if we're looking at that Venn diagram. I'm going to use the formula. So we've got, let's see, 0.6 plus 0.7 minus 0.4. Or you could have just done 0.2 plus 0.3 plus 0.4. You'll get the same thing, which is 0.9 or 90%. And then find the probability that only car A stops. So only A stops means A stops, but B doesn't stop. And that's going to be 0.20. So I don't need to show any other work if I'm using numbers that are already in the table. I can just put what I have on the paper. Okay, on the next page, find the probability that exactly one car stops at the intersection. So exactly one car stops. So this means that one stops or the other, but not both. So if you look back at your table, I could have the 20% of A stopping but B not stopping, or the 30% of B stopping and A not stopping, but I can't include the both. So it's like the addition rule, but thinking about it like a disjoint. We don't want to include the both, but we don't want to. So I don't know. I guess that this is the best way that I would do the problem, is just to use, let me get a highlighter. Oops, come on. Is just to use this number here and this number here and not include the 40%. So again, this number and this number, if I were using the table, I can add those together to find my probability. So that's going to be 0.5. And then find the probability that neither car stops is going to be that 10% that we saw at the bottom of our Venn diagram, or that lower corner of our table. All right, I would suggest pausing the video and trying this last example on your own and seeing how you do. So either Brian or Mark is responsible for cleaning the classroom after school. The probability of Mark cleaning the room is 90%. So Mark cleans 90%. Probability that Brian cleans the room is 80%. The probability that they both clean is 75%. So that leaves me with 15% here, 5% here, 20% to make 1, 10% to make 1, which makes this 5%. The probability that at least one cleans means one cleans or both clean. At least one is one or more. So that's going to be 0.75 plus 0.15 plus 0.05, which gives me 0.95. You could have also done 0.9 plus 0.8 minus 0.75 if you're using the formula. Probability that Brian cleans but Mark doesn't. Brian cleans and Mark doesn't is 0.05. I don't need to show work because it's just one number from the table. I'm just looking directly at the table to get that. Probability that exactly one person cleans. So that's going to be either Brian cleans and Mark doesn't, or Mark cleans and Brian doesn't, but not both. So that's 20%. And no one cleans. That is 5% down in that lower right-hand corner. All right, and that is it for today's lesson.